In today's tech tip, we're going to be talking a little bit about hard drive technology, and specifically, we're going to be talking about SSD hard drives, solid state drives. What are they? How do they compare with older technologies that are already on the market? What sort of benefits do they have? What sort of drawbacks might there be? And are they right for me? All that next on the tech tip. As we delve into SSDs, what they are, how they work, etc., the easiest way to go about that is to contrast them with the technology of a traditional hard drive. In a traditional hard drive, there are spinning platters, disks that spin constantly within that drive in your computer. Now, if your computer needs to read something, it finds the location of that particular file that you're looking for, and as that disk spins around, and it does so fairly fast, anywhere from 5,400 to 7,200 RPM, but as those platters spin around, the computer reads a section of that data in that file for each revolution of the platter. The inherent downside of that is that if it wants to read more data, it has to wait for those platters to make another full revolution back to that original spot, wherever it was at, that it might get the next slice of data. So although those storage platters are spinning around at a fairly good rate, there's also a lot of downtime by virtue of the fact that it's waiting for that next revolution. Let's contrast that with the technology of a solid-state drive. A solid-state drive works very similar to the way you might look at a USB thumb drive, a USB flash drive. It doesn't have any spinning platters. Instead, it stores data on chips known as flash memory. There are two advantages to that. Number one, there is no latency there as you wait for that next revolution of the platter to get that next slice of data that you're either writing or saving. It's all right there on the flash memory and can be accessed almost instantaneously. The other advantage of SSDs and flash memory is that the physical act of writing to that memory is a little bit less intensive than writing to those spinning disks. So you ask, what's the big deal? You have a definite speed difference between an SSD and a conventional spinning hard drive. Some of the circumstances you might actually see a difference if you were to put these things side by side is when you would boot up your machine, whether you're working with Linux, whether you're working with Mac OS X, whether you're working with Windows. You're going to see the computer get at a point where it's going to be usable with that keyboard, with that mouse a lot sooner than it would otherwise, because it's going to be able to access the different files that it needs to load that operating system a lot more quickly because of the design advantages of an SSD. Another potential area where you might see some advantages is if you find yourself working with large files. Say you edit a lot of video or audio, and these files can occasionally be large. To read, and for that matter to save those files on an SSD versus a conventional spinning hard drive is going to be much faster just because of the differences in technology. Therefore, you ought to be able to get more work done more quickly. What I've found from personal experience also is I believe SSDs are more reliable. I'll give you an example. I had a laptop that I use very, very frequently that I had a lot of data on. I used it for about 2 years. After about 2 years, the hard drive went bad on me. It had a conventional hard drive in it. I replaced it with a conventional hard drive of equal size. After about another 2 years, that hard drive that I've now already replaced once went bad a second time. And at this point, I got a little frustrated and I decided to take the leap into solid-state technology. I have absolutely no regrets. I've had this hard drive in this machine now for more than 2 years, and it's not given me a problem, not even once. And I believe the reason for that is that an SSD drive does not have any moving parts. The SSD technology has eliminated a potential weakness in the structure of that drive by virtue of the fact that there's no bearings to go bad, no motors to worry about, this sort of thing. That's not to say that an SSD can't go bad. An SSD and the flash memory contained within it does have certain limitations. Each of those sections or sectors of memory can be written to X number of times. Realistically, however, you're probably going to get a new computer or you're going to upgrade that storage device to a bigger one before that would ever happen. Everybody should have a backup strategy of some variety, and perhaps I'll do a video on backup strategies here another time. But to summarize, you're going to be less likely to experience a problem with an SSD drive versus a conventional hard drive. One of the downsides, at least today, is that an SSD drive versus a conventional spinning hard drive of equal size, that SSD drive is going to cost you more on a per unit basis. As you probably already know, units in a hard drive are measured either in gigabytes or in terabytes. If you break it down on a per terabyte basis, that SSD is going to cost you more. So you have a little bit of a trade-off there between price, performance, and reliability. What does it all boil down to? Well, if you have a workstation where you need speed, if you're playing games even, or if you're doing that video or audio editing that I was talking about, an SSD would offer a definite advantage. Certainly, if you're looking at a new desktop or a laptop, I would certainly look for SSD storage in that desktop or laptop. The one situation where you might stick with a conventional hard drive in today's world, and this is only because of costs, is if you have a situation where you have to store large amounts of data, where the overall storage capacity is probably going to be over that 1 terabyte mark. But prices on SSDs versus the hard drive, that gap is shrinking more and more. Eventually, I think we're going to see SSDs on a per unit basis come down and be a lot closer to what you might see for a conventional hard drive. With today's tech tip, I'm Mike Buckman. Thanks for tuning in. Remember, leave your comments and questions below. I'll try to get to those. And don't forget to like and subscribe.